All right, set A. George, can you tell me what'd you get?
Y equals 1x plus 1.
Okay, and we can actually write that as just y equals x plus 1. Yeah, there's nothing wrong with 1x plus 1. And so, George, what did you notice? Like, what led you to that equation?
Pattern.
What was the pattern? Like, what did you notice?
1 is 2, and then 2 is 3, and 3 is 4. So I noticed that they're all going up by 1, but the y has 1 more, so I was like, alright, see what 0 is, and 0 is 1, so I realized it's plus 1.
Ooh, I like how you thought about that. Okay, so do you see that each one is 1 more than the one above it, and then, so it sounds like you were thinking of your y equals mx plus b, sort of going backwards to the 0 to get that 1. All right, how about set B? Yeah, Alex?
I did y equals negative x.
Okay, and so what did you notice here to come up with that? You're right.
To get negative 2 to 2, you would have to multiply it by negative 2. Or by a negative.
A negative 1, yeah. Okay, awesome. Okay, so now look at the bottom of this slide. It says the second example is an example of direct variation. How is the second equation different from the first one? Yeah. Oh, is your hand up?
Sure.
Okay.
It has multiplication.
It only has multiplication, right? This has addition to it, okay? So when I say what's different, and write this down, there's no constant added in set B. And do you remember yesterday in that exploration, in all the ones that were direct variation, where did the line go through on the graph? 0, 0. It always went through the origin. So direct variation, okay, direct variation is always going to have your graph that's going to go through 0, 0. So if you look at the next slide, it says an overview of direct variation. The statement, y varies directly as x, means that when x increases, y increases by the same factor. We can write it as y equals kx, where k is the constant of variation. So what I want you to do is I want you to circle that. K is the constant of variation. In other words, y and x will always have the same ratio when I take y divided by x equals k. Can you write that right here? So every time you take the y divided by x, it's going to equal k if it's direct variation. And then we have y equals kx is the direct variation formula. Okay? Y equals kx. So you might see it as y varies directly as x. Sometimes it'll say y is directly proportional to x. All right, flip the page when you're ready. And it says, identifying direct variation from tables. Tell whether the data show direct variation. If it's yes, write the equation. So in letter A, I have a set of ordered pairs. What I want you to write down is this. If you take all the y's divided by their corresponding x's and you get the same constant, then it's yes. Write that down. So when you have ordered pairs, okay, when you have ordered pairs, you take y divided by x and see that you get the same constant. So try that in A and B. If you need a calculator, you can grab one or take yours out. Not next week, but the week after, we're going to start using graphing calculators. So if you have not acquired one yet, you need to see if you can purchase one. It's the TI Inspire. You can borrow from somebody, but we will be using them. Not next week, but the week after. So you got a little bit of time to make sure. And they're things that can only be done on the graphing calculator. Alright, so letter A, did you guys get no? It started to look like it was going to be pretty good, but when I took 38 divided by 9, that was not 4. So that's a no. So there's no equation to write. Alright, so now in letter B, I got them all to check. And watch this, you guys, this is really cool. If you write it like this, that you're taking y divided by x is equal to the k value, and I want to write an equation, guess what? All I do is multiply both sides by x, and that gives me the equation. One more thing I want to put here for you is I want you to draw a triangle and watch this. This is going to rock your math world. Watch this. If I'm looking for y, you take k times x. If I'm looking for k, I take y divided by x. And if I want x, I do y divided by k. Let me do this one more time, okay? This is cool. If you're looking for y, you take k times x. If I'm looking for k, I do y divided by x. And if I want x, I do y divided by k. Do you see how that works? It's kind of cool. All right. So, identifying direct variations from equations. So, if you glance through the 4 equations, and I want you to think back to the opening slide that we looked at with this data sets. And what are you wanting to have happen so that the equation shows direct variation?
The y by itself
Get the y by itself, and then what should happen?
should go by a steady rate.
Okay, you're going to solve for y. Okay, you're going to solve for y, and if it's y equals kx, so make sure you write this down in your notes. If it's y equals kx, then it's direct variation. But if you have a plus a number or minus a number, then it's not. So I'm going to pause, and I want you to solve each one of these for y if it's not already solved. And so, what's really neat is you can see from chapter 1, do you remember how I was having you solve for y? Okay, this is why. It was to set you up for success. So here's the first one. Divide by 3 and y equals 7/3 x. Now, if you write 7x over 3, that's not wrong, but it's harder to see what k is. K is what's in front of x. So this is y equals 7/3 x, so k is 7/3. Here in number 2, if I divide by 7, this is not direct variation because I have plus 1. Number 3, subtract 4x, and I get 3y equals negative 4x. Okay, you're trying to solve for y. Okay, you want to get y alone. Divide by 3, y equals negative 4/3 x. So this is a yes. and k is -4/3. Number 4, I would recommend that you rewrite this one. X over 9 is the same thing as 1/9 x. Because I think number 4 looks confusing. So this one's yes, and k is 1/9. Alright, so I want to pause here a moment and make sure we're understanding, because we're going to do like really 4 things really, okay? We're going to look at like 4 things, but 3 of them we'll talk about here. If you have a set of ordered pairs or a table, you take y divided by x and see if it's a constant. If you have an equation, you solve it for y equals kx, and if there's no constant, it's direct variation. Alright, so now, when you're ready, flip, we're almost done. It says the variables x and y vary directly. So anytime I see that, I'm going to write y equals kx. To find k, you take y divided by x. So it was 19.22 divided by 6.2. So use your calculators. And what are you getting for k? .3.1. Now 3.1 is not the equation. The equation is when you plug k in. Alright, so be careful, because I'll see students, I'll say write an equation relating x and y, and they put 3.1, or k equals 3.1. That's not the equation. You need k, but you've got to write the equation. Now it says find y when x is 4.3. So let's plug that in. And I got 13.33. All right, number 2. It says a salesperson's commission varies directly with sales. And so watch this. Like, I know students tend to struggle with word problems, but they're really not bad. Okay, here's what I want you to see, is that this is commission varies directly with sales. So watch how you write it. Remember, it was y varies directly with x. Okay, let's write that down. Y varies directly with x, so we write y equals kx. Okay, write that down. Y varies directly with x is y equals kx. So if I have commission varies directly with sales, I'm going to write it like this. Commission, C, equals K times S. Then they're always going to give you a pair of numbers that go together. Okay, they're going to give you a pair of numbers that go together. The commission is 85 and the sales are 1,000. You can either plug it in here or do C divided by S equals K, like y over x, C over S. So I'm going to divide by 1,000, and K is 0.085. So it's now C equals 0.085 S. What is the commission for $2,300 in sales? So this is a multi-step problem. You've got to write your variation equation, plug in the pair of numbers to find K, use that equation to plug in. Yeah? Yes. And you guys use units. On the test, I was kind to you and wrote a note and said, please include units, but in the future, I'll take off if it's money and you don't put a dollar sign, because like some people said, I don't know what it was, like number of people or whatever, so like it really, you need to indicate what did you find. Alright, so when you have your variables vary directly, y equals kx, or in this case it was commission varies directly with sales, you find k by doing your pair of numbers, and then you can answer for the letter they're looking for. Alright, last one. What is the graph of each direct variation equation? Well, the cool thing is, when you're graphing, direct variation is always through the origin. Okay, let's write that down. Direct variation is always through 0, 0. Then you're going to use slope to find a second point. Okay, direct variation always goes through the origin, 0, 0. So then I'm going to go up 3, right 4, and then draw my line through it. See how easy that is? Here my slope is -2 or -2 over 1. I plot through the origin, so you only need even one point will do the job, because you know the second point is at the origin. So I'm going to go down 2, right 1. Alright, now I would like you to, when you're done graphing this one, I want you to flip it over to the back again, and I want us to do a quick summary. You should have some space, because the warm-up there were only two problems. Alright, write this down on the back. Number 1, when you have a set of ordered pairs or a table of values, what do? Look back through your notes if you need to. Okay, can anybody summarize? What did we do when you have an ordered pair? Set of ordered pairs. How do you determine if it's direct variation?
Oh, you divide them.
Yeah, you take y divided by x and see if it's a constant, okay? So when you are going to work on the homework and they're mixed up, I want you to use your notes like these. These are your guide. When you have an equation, what did we want to do? Yeah, okay, so let's say it this way. Solve for y. If you have y equals mx plus b, where you have a b number other than 0, okay, it can't be 0, then it's a no. And the third one, how do you know if it's direct variation if you look at the graph? What was special about it? Okay, and we need to be careful because we're going to look at things other than lines this year. So it's a line through the origin. Okay, it's a line through the origin.